Welcome to the DIY Honda Garage channel. DTC P1297 indicates an ELD circuit low voltage issue, which is crucial for the proper operation of the vehicle's electrical systems. The ELD, or Electric Load Detector, is a significant component that senses the electrical load and communicates this information to the Powertrain Control Module, or PCM. The PCM relies on this data to optimize engine performance and ensure efficient electrical consumption. When the circuit reports low voltage, it may trigger a warning in the system, indicating a fault that needs addressing. Effectively troubleshooting this code involves verifying the electric load values and ensuring connections are intact throughout the relevant circuitry. If not rectified, further issues could arise in overall vehicle performance. The Electric Load Detector, or ELD, is positioned in the under-hood fuse/relay box of the Honda CRV, typically near the battery or main relay. This component continuously monitors the vehicle's electric load by measuring the current flowing through, which it sends to the Powertrain Control Module. By assessing this data, the PCM can adjust the vehicle's performance and optimize its electrical system consumption. If the ELD detects low voltage, it indicates that the electrical load might be insufficient, potentially causing various performance issues. Regular checking of the ELD is vital to ensure reliable communication between this component and the PCM, as failure in this circuit can lead to broader electrical issues within the vehicle. Several factors can contribute to the P1297 error code. Poor wiring connections can interrupt the signal flow between the ELD and the PCM, leading to erroneous readings. Similarly, loose terminals in the underhood fuse relay box or at the PCM can create intermittent connections, triggering the low voltage signal. Additionally, if the ELD itself is malfunctioning, it may not effectively report the correct electrical load. Another possible cause could be a defective PCM, particularly if the software is outdated or has been incorrectly calibrated. Identifying the exact cause requires thorough diagnostics, including visual inspections and electronic tests, to isolate the problem accurately. When DTC P1297 occurs, drivers may experience a range of symptoms, many of which relate to engine performance and overall vehicle efficiency. Commonly observed issues include a decrease in engine performance, as the PCM struggles to optimize based on incorrect data from the ELD. Additionally, dashboard warning lights may illuminate, signaling to the driver that there's a fault that requires attention. Inconsistent electrical operation might be noted, affecting functions such as headlights, power windows, and other electronic subsystems. Furthermore, a reduction in fuel efficiency may also be observed, stemming from the PCM's inability to manage electrical use efficiently. Thus, recognizing these symptoms early is crucial for maintaining vehicle integrity. The initial step in troubleshooting DTC P1297 involves turning the ignition switch to the on position and utilizing the Honda Diagnostic System, or HDS, to check parameters. You will want to look specifically at the electric load value, which should be more than 72 amperes for normal operation. If this current condition matches the threshold, it confirms that the failure is indeed present and requires further investigation. However, if the values do not meet the threshold, it suggests that you may be dealing with an intermittent failure. In this case, it is vital to check for poor connections or loose terminals at both the underhood fuse/relay box and the PCM to ensure that electrical signaling is intact before proceeding. In the second troubleshooting step, you again turn the ignition switch to lock position for safety, and then disconnect the 3P connector from the underhood fuse/relay box. This step is essential as it isolates the ELD circuit to identify if the problem rests within this component. After disconnection, power the ignition back to the on position and then check the electric load value once again using the HDS. The expected threshold of more than 72 amps must match the current conditions. If the values align, this suggests that the problem may lie within the ELD itself. Conversely, if the reading does not meet expectations, the next course of action is to replace the ELD and then perform repair verification. For the third step, the troubleshooting process continues by once again ensuring the ignition switch is turned to the lock position. Next, you will jump the SCS line using the HDS, which stands for the Service Check Connector. This allows for a more thorough evaluation of the circuit. Following this, the PCM connector A, often termed 49P, is disconnected. It is crucial to check the continuity between specified test points. Point 1 is located at the PCM connector A terminal number 34, WHT, and point 2 is the body ground. Successful continuity indicates that there is a short in the ELD wire between the PCM and the underhood fuse relay box. If continuity is absent, this suggests the ELD wire remains intact, necessitating an update of the PCM software or replacing it with a known good unit. Vital steps in the repair verification process begin with ensuring that all the connectors are properly reconnected, including those at the underhood fuse/relay box and the PCM. After reconnecting components, the next critical action is to reset the PCM via the HDS. This step is paramount as it clears any stored codes in the module and prepares it for new data inputs. Following the reset, the PCM idle learn procedure should be performed, ensuring the engine can adjust itself after meaningfully changing its parameters. Once these actions are completed, start the engine and turn on the headlights to monitor for any recurring codes. These checks are vital in ensuring that the repair was effective, providing the necessary confidence that the issue of low voltage in the ELD circuit has been resolved. Preventive maintenance plays a vital role in avoiding future issues indicated by DTC P1297. Regular inspections of connectors, especially those at the underhood fuse relay box and the PCM, can prevent loose connections from becoming problematic. It's advisable to periodically monitor the vehicle's electrical load readings to identify potential issues before they escalate. Moreover, ensuring that the PCM software is kept updated can mitigate risks of challenges related to incorrect data processing. Vigilant care with these components will foster a reliable electrical system, enhancing the vehicle's overall performance while preventing the recurrence of low-voltage signals in the ELD circuit. In conclusion, comprehensively understanding the role of the electric load detector and its communication with the powertrain control module is essential for troubleshooting DTC P1297. This code signifies a critical issue in the vehicle's electrical system, affecting performance and potentially leading to broader complications if not addressed timely. Thorough inspections of wiring connections and component integrity are vital in diagnosing the true cause of low-voltage signals. Proper reset and verification procedures must be conducted after repairs to ensure effective solutions. Finally, adopting preventive maintenance measures further enhances reliability, reducing vulnerability to similar issues in the future. Engaging with these processes expediently can greatly promote optimal vehicle functionality. Please like and subscribe to the channel. See you next time!